Okay, let's get started. Now we're going to cover section 13.5, measures of dispersion. Let's talk a second about what the word dispersion means. When you disperse something, you spread it out. Okay, so we're going to be measuring the spread. Okay. There are two measures for dispersion to be covered in this section. These measures of dispersion are used to represent the spread of the data. The first one is called the range. You've probably heard of it before. It's the difference between the highest and the lowest values. So to calculate the range, we simply take the highest value and subtract the lowest value. And what the answer is, that is the range, okay? That indicates the spread, how spread out the data is from the high to the low. Then we have the standard deviation. The standard deviation measures how much the data differ from the mean. Okay, standard means on the average. Deviation means how far they deviate from the average. So this is the average of the deviations from the average. Average of the deviations from the mean. Okay, we have several measures for average, right? The mean is the measure that we're specifically talking about here. So we're going to take the deviations, measure how far things are from the mean, and average those up to calculate the standard deviation. Here's the formula that is being used. We actually are going to do most of these on the calculator. I'm going to show you how the calculations work by doing a couple of examples the long way, and then we will actually do all of them from there on with your calculator, which is required that you have for the class, so you might as well use it, okay? These steps I'm going to actually do as we go through our first example. So if you'll turn to the next page, you can keep that handy and look at the steps as we're going. This first problem says, let me turn to that page. 7 employees at a large company were asked the number of additional years they plan to work before retirement. Their responses were 10, 23, 28, 4, 1, 6, and 12. Determine the range and standard deviation of the number of years. So I'm going to go above this and calculate the range. Looking for a pen, that's what I'm looking for here. Okay, the range is going to be what we get when we take the highest value, and the most anyone plans to work is 28 years, and we subtract the lowest, one person only plans to work 1 year, so there's a 27-year range between when the first person plans to retire and when the last one will be retiring. 27-year range. Okay, that's the easy one. And now we want to do the standard deviation, and so we are going to follow the steps on the page before, and it says first, find the mean of the set of data, and then make a chart having 3 columns. Okay, so to find the mean of the data, we can go ahead and put that in our calculator. I will turn mine on and clear. Let's see. I need to put some data in. Oh, I can tell there's already data in there. So I go to the second stat bar and I arrow over twice to get the clear data. Hit enter. And it clears out the data. Now I'm ready to begin by putting in my data. The first X value is 10. Arrow down twice for that because we have only one of those. A 23. I arrowed over for some reason. Arrow down. And this is the X3 value, which is there. That's better. Not as much glare on the screen. 28. We only have one of those. 4. One of those. We have a 1. Arrow down. 6. Arrow down. 12. Arrow down. Okay, and it says we're ready for the 8th score. We've put in 1, 2, 3, 4, 5, 6, 7 numbers, so that looks good. Now I'm going to go stat var right here. And it says the number of things entered were 7. Good, at least we got the right number. And we move over 1, and the x with a bar over it tells us the average. And we see that the mean of these would be 12. Okay. So the first thing I do is I calculate the average, and the average is 12. Remember, that's our symbol for mean, for the mean. Okay, it says to make a chart having 3 columns. Data. Okay, so the first column is going to be data. And the next column is going to be the data minus the mean. That will show the deviation. And then the next column is going to be the data minus the mean squared. Okay, so let's fill this in. And the data that we were given on this particular problem, 10, 23, 28, 4, 1, 6, and 12. All right, take a pencil here, make myself some lines to work with. Okay, looks good. Now I'm supposed to take the data and subtract the mean. So the mean is 12, so I'm going to take 10 minus 12. And so this data item is 2 deviations below the mean. Okay, that's measuring the deviations. It's 2 below. The negative means it's below. All right, so we take 23 minus the mean of 12. And we get that this one is 11 deviations. It's positive, so it would be 11 deviations above. Then we take 28 minus 12, always subtracting the mean. So this is the data minus the mean. And we get 16, positive 16. 4 minus 12 will give us a negative 8. 1 minus 12 will give us a negative 11. 6 minus 12, a negative 6. And finally, 12 minus 12. How many deviations is that from the average? It's right on the average, so it deviates 0, which is what we would expect. Now, since these are positive and negative, it's necessary for us to square these. So we now take what we got before. That was the deviation, right? The data minus the mean. Notice that this is the same thing as that, but now we have to square it. So I'm going to take a negative 2 squared, an 11 squared, 16 squared, negative 8 squared, negative 11 squared, negative 6 squared, and finally 0 squared, okay? Go ahead and calculate each of these. These are the squared deviations. Okay, negative 2 squared is positive 4. 11 squared is 121. Positive. All these are positive because when you square it, it makes it positive. 16 squared is 256. And negative 8 squared, negative 8 times negative 8 is positive 64. Negative 11 times negative 11 is positive 121. Negative 6 times negative 6, 36. 0 squared is 0. Okay, so those are the squared deviations. All right, reading the steps again that they're describing for us to do. We square the values. We've done all that. We're ready for step number 6. We've done the first 5 steps. Step 6 says determine the sum of the values in the data minus the mean column. So we want to take this column and get the sum. The sum, of course, means that we want to add all those together. So I'm going to take the sum of that column. Here we go. 4 plus 121 plus 256 plus 64 plus 121 plus 36 plus 0. The sum is equal to 602. That is the sum of the squares of the deviations. Okay, that was step 7. No, 6. 7 says divide this sum. Divide the sum, 602, by n minus 1. Okay, I'm going to write down here n minus 1. N is the number of data items that we have. In this particular thing, we had 7 pieces of data. We subtract 1 from that. So they want us to divide this by n minus 1, which would be 6 in this case, because it's 7 minus 1 is 6. Okay, so I take that on my calculator, divide it by 6, and it's a not so lovely number. It is 100.3. Repeating, leave that displayed on your calculator. Okay, you don't want to round it because you'll introduce a rounding error. And then finally it says determine the square root of this number that you've obtained. Okay, so we need to square root this. Square root of 100.33, repeating. Okay, and so on your calculator you'll see the square root button is right down here, the second option of the x squared. So hit second x squared. And now if you'll find the answer, which is the second option of this button right here, so you go second, the negative sign, and it's going to take the square root of the answer that you had before. And we know that the square root of 100 is going to be about 10, and so it's going to be approximately 10.02 rounded to the nearest hundredth, okay? So on the average, these deviate 10 units from the mean, which was 12, okay? The average of the deviations is 10.02. And they should tell you, and I will tell you on the test, how to round to the 10th or the 100th or whatever. So that is the standard deviation. We use the letter S to represent the sample standard deviation, which is what we'll be using in this class. If you had a statistics class, you may have done a population standard deviation and use the n, but we will be using the sample with an n minus 1 for all the problems that we'll be working with in this textbook. Okay. All right, let's do another example using the same type procedure. Actually, let's check this on the calculator now. Let's go back to StatVar. Remember, we put this data in here a little bit ago to calculate the average, and we moved over 1 and it said that the average was 12. Let's move over 1 more to where the S is, and look, isn't that number familiar? This is the sample standard deviation. So on our calculator, if we put the data in just like we would to calculate the mean, the one that says S X is the sample standard deviation. This is the one we'll want, and it's, as you can see, it's the third thing. You have n, the mean, and then the sample standard deviation. That's what we use. That's the population, which again we're not using, but you may have used it in another course, and you may use it in some other course yet. Okay, so I'm going to clear that, and we'll do the next one. On the next one, I'm going to go straight to working it with my calculator, which will definitely speed us up. It says this is about prescription prices. The amount of money 7 people spent, 7 people again, on prescription medication in a year is as follows. Okay, so here's the data that we want to use. Determine the range and the standard deviation. You will have a question on the next test that will have you find the range and one with the standard deviation, or maybe one that has both. Okay, so for the range, I read through these and I find the highest value, which appears to be 850, high minus the low, and the lowest value is 100. So there is a $750 range in the prices paid of the 7 people from the high to the low. That's the range. And now we want to do the standard deviation. Okay, and we're going to do this on the calculator. So pull out your calculator. And if I go to the data to enter data, oh, of course, there's data in there already. So I do second, hit the data, and I arrow over twice and clear the data. Okay, now I go back into the data and I'm going to enter the data. So we have a 600. That's the first value. Arrow down twice because we only have one frequency of that. 100. Well, it doesn't look like it got my other 0. 100. arrow down. Make sure that you enter the data correctly. That's the only part to really worry with here. 850, one of those. 350, one of those. 250, one of those. And 140, arrow down. And the final score is a 300. Okay, so we're ready for the 8th score, and we've put in 7, and that's how many we had, so we're good. And now we want to hit stat var and get the statistical variables. It tells us that the number of data that we placed in were 7. The average was 370, and the next one, I'll go ahead and write this down. The sample standard deviation, SX, is going to be, let's round again to the nearest hundredth, 267.33. So the average of the deviations for this would be 267.33. Good? All right, and one final example. These are not too hard. You'll just have to get your calculator out and practice a few with your calculator. The final example is, hold on, I seem to have misplaced that. Okay. All right, this is fine. It says, without actually doing the calculations, decide which, if either, of the following two sets of data will have the greater standard deviation. So, without doing calculations, figure out which one has the greater standard deviation. Okay, this is not focused terribly well. Let me circle this and see if I can get the thing to focus better. Okay, so this is my first sample, and I'll draw a line there to separate. The first one has a 10, 13, 14, 15, 17, and 21. So my lowest is a 10 and my highest is a 21, and it looks like they're kind of equally spread out, and the middle is going to be somewhere probably right around 14, 15, right? And look at these. They go from 16 to 19. So first of all, which would have the bigger range? Remember, the range is the high minus the low. Yes, the range is larger on this first one. The range here is 11, and the range down here is only 3, okay? So this is spread out, more spread out. The data is more spread out from the low to the high, and it would have a higher standard deviation. And we can just tell that because it's more spread out. If you average the deviations from the average, they have to be greater. This is all close together, right around 17, 17 and a half. It's very tightly fitting in there, okay? So there will be maybe a concept question, of course. Let me point out that on the test, it would not be a bad idea to use your calculator and put the data in and actually calculate the standard deviation to verify your answer. Even though it says not to, on the test you would be allowed to use your calculator to verify your answer, okay? So if I ask you to justify it or explain it, you would have to say something like we said here. It is more spread out, so it would have a higher standard deviation. All right, thank you very much. We're done with 3.4, and I'll be seeing you soon. Bye.